Hello everyone, I'm Hardeep here. Let's wait for a minute before starting the class. All right, let's get started. Okay, so hi everyone, I'm Hardeep and I will be your instructor for this Hadoop certification course, Hadoop and Big Data certification course for the next 10 sessions. Okay, the duration of each session would be 3 hours. Okay, you should have good internet connectivity, at least 2 Mbps and a ping rate of at least less than 150 milliseconds. If it's less than 90, that would be perfect. Yeah, you can check your speed at www.speedtest.net. If you're facing any issues, you can always reach to the support team at the number specified. So is everyone able to hear my voice and see my screen? So at the right side of your GoToWebinar, there's a question panel. You can just type in why or no. Okay, I'm getting yes from everyone. That's great. Perfect. In the future sessions, if you are facing any issues connecting, you can troubleshoot. Okay, you can use the question panel to raise the concern so that I can help you, and make sure you're using a computer audio. Okay? Make sure your microphone is working fine. And if you're still not able to hear me or see the screen, you can disconnect and rejoin the session. About the audio. So attendees audio, so everyone, your audio would be muted by default. Okay, and it would be presented via the GoToWebinar audio. Before joining the class, check your computer's audio and headset for audio clarity. In case of any issues, please raise concern in question panel and rejoin the session. For me, for the instructor, so in case if I'm not audible or if you hear background noise or sounds, please do let me know. Please don't hesitate. And in case if I disconnect or the connection is lost at my end, please you all don't disconnect. I might be trying to reconnect using a backup internet connection. So in the course of the session, there might be cases where I need to share additional notes, some data set or assignments. So in the GoToWebinar panel, there is a handout section. So in case I need to share something, I'll place the document in the handout section. You can download the document from there. Hi, so I got a question from Chaitanya. So hi, this is Chaitanya. Hey Chaitanya, so we will be soon, so thanks for joining. We haven't started with the introductions yet. We will soon start it. Okay. Now in case of questions, in case of queries, okay, so please feel free to ask questions. Okay, the more you ask, the more you will get about this topic. Okay, I understand big data is a very vast topic. So the more you will ask, the in-depth knowledge you will get about this topic. Be direct, be clear, and be specific. How will you ask questions? So put your queries in the questions section of the GoToWebinar panel. I will read it aloud to all the participants with the name of the participant who asked the question, so that all of us are on the same track. Okay. So if a question is asked by one participant, it won't be visible to all. It would be just visible to me. Right? So just to keep the entire class on the same track, I will read the question aloud. If the question is related to the topic which I am covering, I'll try to take it there itself. But if questions are complex and I feel that it may trigger some additional discussion, we will discuss these in logical breaks or probably at the end of session. Okay. Yes, Chaitanya, so you have raised your hand. Is there any issue at your end? You can just type in your issues in the question panel. Okay, it was by mistake. All right, no issues. Okay. Now, if you feel that the question is misunderstood by me, please rephrase it or ask me to unmute you so that I can understand the question clearly. And in case the question is very urgent, you can ask me to unmute. Okay, if you feel the question is very urgent and it's something that you are not able to type it, you're not able to phrase it, you can ask me to unmute you. Okay. Now about the breaks. Okay. So we would be having two logical breaks. Now what is a logical break basically? So the questions which we have parked or the complex questions, we can trigger those discussions in these logical breaks. So it would be around a 5-minute logical break. The first break would be at 45 minutes. Okay. That's roughly around 9:15 p.m. And the second logical break would be at 1:35 minutes. That's roughly around 10:45 p.m. We will be having one energy break of around 5 to 10 minutes. That's 45 minutes after the first logical break. That's around 10 p.m. So you can have a sip of water or you can stretch yourself, right? You can have a bio break. Now required software for this session. Okay, required software, the support which Edureka is giving you, an introduction to your learning management system, that's LMS. So for software, you require to install Oracle VirtualBox or VMware, anything. Okay. You have to install Hadoop VM, okay, and or PuTTY, right? So PuTTY is a Linux client for Windows. Okay, you should have a hardware of minimum 4 GB of RAM and a dual core processor. Okay, if you're not able to meet these hardware requirements, then you can simply use PuTTY. Okay, so Edureka has a Hadoop cluster on cloud, so you can connect to that cluster using PuTTY from your Windows itself. In case of issues while installation or any other issues, okay, you can reach out to the support team. It's a 24/7 support team. Okay. In case you have some questions which did not click you while the session was on, you can, and if you want me to ask that later, you can go to your Edureka website. Okay, you can raise a support ticket and you can mention my name there. Right. So as I mentioned, I am Hardeep. Okay, so you can mention my name. The questions would be redirected to me. Right. There is also a discussion forum available at Edureka's website for you to connect and solve your problems. Now let's look out LMS. So we'll have a quick walkthrough of what is LMS. Right? So if you have seen the Edureka website, right, this is how it looks like. Right, there's a section go to batch LMS. Okay, so this is all the reference materials which are available for you for the entire duration of the course. Okay, so there are multiple sections. There's a getting started section. Right, so this is about Hadoop, about the course. about the certification training, right? This is about your hardware and software requirements for Hadoop, and this is a guide how to use LMS, right? Now, in case if you're facing any issues while installing Hadoop or the softwares which are mentioned, you can, as mentioned, you can contact the support team. So there's a installation guide available here. It's a pretty detailed installation guide. For your reference, there are pre-recorded videos also available for the entire 10 sessions which we would be taking. So it's just for your reference. Please, it's a kind request. Please don't compare how the trainer is teaching in these recordings and how I am teaching. Everyone has a different pattern of teaching. I have a different one. Okay. This is about the course contents. Now, it's a prerequisite for Hadoop that you should know basics of Java. So I'm not asking for advanced concepts of Java, just the basic concepts, right? So if you're not acquainted with basic Java concepts, so there's a entire essentials for this Java, entire video guide and presentations. So I request you, before coming to the next weekend session, kindly go through this. This is the guide for the VM installation, and you can download the VM. And this is how, for every module, you will be having various presentations, quizzes, assignments, and reference material. Okay. A kind request. So when and where we are finishing the presentation, kindly go ahead and take the assignments and quizzes. Okay. So this will help you understand where you stand exactly in understanding the topic. Right? If you have any doubts in solving the quizzes or assignments, feel free to raise a support ticket, or we can discuss in the next session. Right? Now, how will you raise support tickets? Right? So in your LMS, there's a button here, support. You can just go to the support. Right? You can select the course. Right? So if you have taken multiple courses, there would be multiple entries here. Please select the appropriate entry. Select the category. It's a technical, non-technical, or it's a general discussion, right? And you can write your questions here, and in descriptions, if you're redirecting it to me, you can add my name here, right? In case if you want to attach a file, there's a facility here to attach a file. Okay, so Bhaskar is saying that he's logged into Edureka, but he's not able to see the LMS. Okay, so Bhaskar, are you on the same screen where I am? There is no link for go to batch LMS. There might be somewhere in the right side or below the course. Did you find it? Okay, so you have a link to go to the course. So if you click that link, when you will enter the course, you will have a link for go to batch LMS inside the course. Okay. So let me know if you can find it. Hey, Bhaskar, are you able to find it? Okay, let's continue. Okay. Now, if you log into this Edureka website, so if you can see your name here, so if you click on your name, right, there's a link to forums, right? The things which I had mentioned. So there's a general discussion forum available with Edureka. So there's a community forum and there's a batch forum. Right? So these are all the topics. So if you're looking for something, you can search for the topic here. If the topic is not available, you can create your own thread. All right. Now there's plenty of material available on LMS for you to refer. And the best thing is these material are for lifetime. Okay, you will be having access to LMS for lifetime. Just one thing, guys. So the presentation which we saw in LMS, the presentations are only view only. Okay, you cannot download the presentations. You cannot download the PPTs. Okay. So whenever you want to refer the PPTs, you can log into LMS and just refer it. Okay, so as mentioned, please complete the assignments and attempt the quizzes for increasing your knowledge about the topic. Also, every session would be recorded, all right? And the recordings would be made available to you on LMS after 8 hours of the session. So whatever we are doing now, it's all live, all right? So you'll be able to look at these recordings for lifetime, all right? After, and which will be made available after 8 hours. Right? Now, at the end of every session, right? So we have 10 sessions. At the end of every session, there would be a survey feedback form. Now, the survey feedback form is very important, guys. Right? So please fill in the survey after every session. Now, why it is important? So it will help us to find any gaps in your understanding and our explanation and enhance our capability to give you the best learning experience at Edureka. So we understand that you're investing your money and efforts and time in the sessions, right? So your surveys will help us to enhance our capabilities. Okay. All right, guys. So let's get started. Let's get introduced to ourselves, right? So I want everyone to introduce yourself, right? So what I want you to do is just type in your introduction in the questions window. And what I want you to mention, I want you to mention your name, your location, your professional background, and what are the expectations from these sessions, right? So I will read all the introductions aloud in front of all the participants, right? So you can start giving your introduction. All right, so I got the first introduction from Abhilash. So hey Abhilash, so he's from Michigan, right? Jayesh, he's from Texas. And Jayesh is an Oracle BI architect. Okay. Chaitanya, he's also from US and he's a manager in CTS. Okay. We have Chagan, who is from London, and I am data migration and BI consultant. Great. Okay, so we have Bhaskar. He's working with Oracle ERP application and good knowledge in Oracle RDBMS. Great. And Bhaskar is from Texas. Right? So we have Isaac. Right? Isaac is from India, Punjab. Okay. We have Sandeep. Okay. He's currently located in Iowa and working as a data analyst. Okay. We have Rahul Jain from Dubai. He's a Java developer with a good command on big data. Okay. Right. Isaac is a student. Great. Right. So we have Kishore. He's from US, having 6.5 years of experience in production engineering, Python, Perl, Shell, Sybase, ETL. Great. Right. So we have Karthik from New Jersey, right? Technical PM with 10 plus years of hands-on in ES400 DB2, and he wants an overview on Hadoop. Right. So we have Srini, works as a support manager in Citibank Dallas. I would like to learn big data as a new project is going to start in few months. Great. So we have Minesh Patil, right, again from Dallas. He's a BI architect and trying to understand and may utilize big data in future project. Right, so we have Kodanda Rao. Please don't mind if I have pronounced it wrong. From US. Okay, he's working on mainframe, Python, and QA as background. Right, we have Sai from Dallas. He's a Selenium tester, again from Dallas. Great. So I think we are done with all the introductions. Right. So I'll introduce myself, guys. Right. So hi everyone. Welcome to Edureka. I'm Hardeep.
Hey, I just got a technical glitch from my side. Is everyone still able to hear me? Okay, yeah. Okay, I understand there's a little background noise, so I think it should be better now. All right. So I was introducing myself, right? I have 9+ years of experience in software development. I started my career as a Java developer and then switched to big data and Hadoop, and it's been roughly around more than 5 years working in Hadoop now. I'm a Cloudera certified Hadoop developer, right, which is an international grade Hadoop certification. When I started working on Hadoop, it was very new and very less people knew about it. So just out of my interest, I started taking classroom trainings. In my current organization, I'm a lead instructor in my and have helped in setting up Hadoop clusters for multiple projects. I've contributed to many fast-paced research and in-depth explorations, and I'm known for my profound expertise in big data and recognized as a professional big data trainer in my current organization. About my projects, I have worked on various big data projects, right? So which includes, so basically my organization is a pharma domain company, right? So we have all the pharma domain and we are working with clients from the US. Right? So initially all the pharma data, the commercial data, right? We have the sales rep data, right? We have the rules engine. All of this data was initially in Teradata. So Teradata is basically a database which says it can handle big data. But we noticed that Teradata was giving us some issues and it was very expensive, right? They used to charge us $1 million per year just for maintenance, right? There's an additional cost for the hardware setup. So what we did is we migrated the entire setup, the entire data from Teradata system to Hadoop. right? So I was a part of that project, right? It was a huge team. It was a project around 8 months to a year. Okay. Then I've worked with other projects. So we have worked with patient data and the claim data, right? So there are multiple vendors, data vendors. For example, IMS, which provides the doctor prescription data to us, right? The patient data, the claims data. So the size of the data is very huge, right? We get around 7 TB data per week, right? So it's a very huge data. This project basically involved ingesting this huge amount of data, creating reports out of these data, right? Then we have worked with the manufacturing data also, right? So as a part of manufacturing data, so the client they manufacture multiple drugs, right? And the entire manufacturing data, so they have the manufacturing sites across the globe at 10 places, right? So they have a manufacturing site at, say, Los Angeles, right? They have a manufacturing site at Singapore, at Amsterdam, right? At Netherlands. So there are multiple disparate systems in which they're manufacturing data, okay? Manufacturing drugs, right? So what they used to do earlier was, so let's say for a particular drug, right, for manufacturing there are multiple parameters. For example, pH, right? For example, temperature. Okay, let's say I'm manufacturing a drug XYZ, right? Doesn't matter if I'm manufacturing it in Los Angeles or if I'm manufacturing it in Singapore, right? The parameter should have the same value, right? There's a buffer range of that parameter. Now, when the clients wanted to check the values of these parameters, they used to connect to the Singapore system separately. They used to connect to the Los Angeles system separately. And imagine the time they used to take to compare these separate disparate systems report. So what we did as a part of this project is we created something called as a data lake, right? So it's an award-winning solution which we created. It's called as EDL. It stands for Enterprise Data Lake, right? What we did is we brought the entire 10 sites data across the globe at a single location, right? Inside a single umbrella. Right? Once we have, and it was a huge, massive data, right? That's why we have named it as a data lake. Okay. Once we have the entire data under one roof, it was very simple for us to create reports and make comparisons across sites for a single product, a single drug, and a single parameter. So initially, where they used to take around 4 to 5 days to compare a parameter, now it takes just 4 to 5 minutes. Right? That was a huge solution which we had created. Right? And this EDL, it's basically a Hadoop cluster, which is a combination of on cloud and on premise. Right? So we have massive Hadoop clusters. Okay? When I say massive, I'm not talking about the number of machines. I'm actually talking about the capacity of each machine. Right? So we have a cluster ranging from a 5-node cluster to a 25-node cluster. Right? And the storage and the memory we have for a 5-node cluster, we have a RAM of 1 TB. That's a huge memory we have. Right? Every machine is a 256 GB RAM. Right? And the storage, yeah, it's around 1 petabyte. Right? Now, once we have all this manufacturing data, so the client was very happy. They wanted us to ingest the instrument data also. Right? So in pharma domain, so when you're manufacturing this data, so the instruments which are used, for example, a bioreactor, which is used for manufacturing, right? So the manufacturing data, so every instrument has lots of sensors attached to it, right? Which is giving data at a rate of milliseconds. Right? So we have also ingested all the millisecond sensor data into the system, and the data is very massive, right? It's around 1 TB of data which we get in around 4 to 5 hours, right? And it's running 24/7. So it's a huge, massive volume of data which we are storing and which we are processing. Right? Then once we have the manufacturing data, we have all the instrument data. Then there was a requirement for all the laboratory experiment data. Right? Now see, once we have a data lake, so there are lots of requirements. Okay, so Isaac says the display got freezed. So Isaac, you're able to hear me, right? I haven't moved the screen. It's on the same page. I'm still on the introduction page. Okay. Yeah, so once we have the entire platform, the data lake, so there was a requirement for ingesting laboratory data. So the client has multiple scientists, right, which are doing experiments. So it was the same issue. There are scientists in Singapore, right? There are scientists in Los Angeles. There are scientists in Netherlands, right? A scientist at location A does not know if the experiment is performed at location B or not. Right? So to avoid reinventing the wheel, right, we brought all the lab data, all the experiments data under EDL. Right? So it's serving as a common platform for multiple types of data. Right? So these were the projects, and this is an ongoing project. We are getting, so once we have created the lake, now we are getting more and more applications. Right? So I'm still working on the same project. Right? Now let's see what we are going to discuss in the entire module. Right? So there are 10 modules inside this course. The first module would be understanding what is big data in Hadoop. The second module, so Hadoop is actually a combination of it's a combination of two different frameworks. Right? One framework is used for storing, that is what we call as HDFS. Right? So the storage framework of Hadoop we will discuss in module 2. Once we store the data, we need to process the data. So for processing, there's a separate module, right? That's called as MapReduce. Right? So we will look at the processing framework of Hadoop in the module 3. Then we will look at some advanced concepts for this processing framework in the module 4, that is advanced MapReduce. So basically Hadoop, the core Hadoop is HDFS and this MapReduce. This is the core Hadoop. Using the core Hadoop, there are lots of applications created around Hadoop which having the HDFS and MapReduce as the heart. So one of the framework which uses Hadoop, the application is Pig. Now the name is very tricky. So basically Pig is a framework which is created by Yahoo, right? And it is basically a scripting kind of a language which converts your scripts into a MapReduce program which processes your data which is there on HDFS. And so if you see, it's all interlinked. Right? So we will study more in details about Pig in module 5. Similar to Pig, there is another framework called as Hive. So basically Hive, it's a SQL layer, right? It gives you a capability to write a SQL query. Right? This framework was developed by Facebook, right? So you can imagine Facebook is using Hadoop. They're using it so extensively that they have developed a framework for it. So what Hive does basically, it converts your SQL queries again to a MapReduce job, right? Which will fetch data from your HDFS. So we have a question that there are many projects using Apache Spark instead of MapReduce. So are we covering Spark in depth in this course? So Kodandaram, we are not covering Spark in depth in this course. Right? We have a separate course for Spark on Edureka. So after this course, probably you can register for that in-depth Spark course. Okay. We'll be looking at the introductory level of Spark. It's not very detailed. Right? That answers your question. Okay. Right. So yeah. So after Hive, we would be looking at advanced concepts of Hive and HBase. So HBase is basically a database, right, which works with Hadoop. Right? It's a NoSQL database, as it is called. Right? So Hive. Okay. So I have a question that who invented Spark? So basically, Spark was, it's a community who is inventing Spark, right? It's a Apache community who has developed Spark and who is working on it. Okay, so in the module 7, we'll look at Hive, advanced Hive and HBase. Okay, in module 8, we will look at advanced concepts of HBase, right? Like the filter logic and all. Right? In module 9, we'll be looking at Spark, right? That's the next generation MapReduce. It's an in-memory processing framework, right? So it's a very hot topic in market, Apache Spark. Right? So we will discuss about Apache Spark in the module 9. Right? And lastly, we will discuss about Uzi, and we'll be doing a Hadoop project in module 10. So basically, Uzi, it's a scheduler, right? It's a scheduler for Hadoop. Okay, let's say if you want to write multiple jobs, you want to create a workflow of jobs, right? You want to schedule your jobs, you can use Uzi, right? And Hadoop project, basically, it would be an ongoing project, right? The details of Hadoop project is there on your LMS. So basically, we will start doing Hadoop project when we are finished with, say, module 3. When we are almost finished with the core Hadoop part. That's your HDFS and MapReduce. So once we are done with the module 3, we can start with the Hadoop project. Right? Okay, so So I got a question from Minesh. So is Java the only script used in big data, or it can be used, or Python, or it can be used with Python or Scala? So Minesh, so big data, it's not a technology basically. It's a problem statement, right? Big data is a problem which everyone is facing. For this problem, there are multiple frameworks available. Hadoop is just one of them, right? And Hadoop is also not a language, right? It's a framework, right? The framework, yeah, I know the framework is written in Java, but it's a general framework, right? For using Hadoop, you can use it with Python, right? You can use it with Scala, right? You can use it with Java. You can use it with Ruby also, right? So it's not language specific, right? You can use any language for doing your codes on big data on Hadoop. That answers your question. So Chaitanya says, can I use .NET? Yes, Chaitanya, you can use .NET. Right? Right. So Bhaskar says, then we need to know Java. Why? Right? So the reason is Bhaskar. So Hadoop is implemented in Java. So even if you use Python, if there is a issue in your code, or if you want to debug your code, you won't be getting Python errors. You will be getting Java exceptions, right? Because ultimately, if you're writing in Python, Hadoop will convert it to a streaming Java job, and it will run as Java, right? So if you want to debug, if you want to see what is the exact problem in your code, you should know Java to at least understand what was the problem. All right. We have a question from Shri at HBase is also a framework. Yes, Shri, HBase is also a framework. No, it's not exactly a framework, it's a database, right? It's a NoSQL database, right? HBase is also written in Java, but it's more like a database. So let's start with the sessions. So I'll go to LMS. the module 1 and I'll start the presentation. Right, so we have a question from Bhaskar. Pick, Hive, HBase, all are also part of Hadoop. Yes, Bhaskar. Right. So Pick, Hive, HBase, these all are part of Hadoop. So it's basically called as a Hadoop ecosystem. Right. So it's all this, these technologies, these frameworks are a part of your Hadoop stack. So apart from, so the Hadoop stack is growing so fast, right, that you can say every month a new tool is added into the Hadoop ecosystem. So it's not only Pig, Hive, HBase, right? There are other frameworks like Scoop, right? You have Spark, right? You have Yarn, then you have Kafka, right? There are lots of frameworks. See, a single person cannot know everything. The main thing that you should need to know is the core Hadoop, right? That's your HDFS and MapReduce. So once you're well acquainted with HDFS and MapReduce, these frameworks, see, frameworks are meant to make your life simple, correct? And so when I say, like, if I just consider an example of Hive, if I was not having Hive and if I have structured kind of a data, if I want to query data, I need to write a program for that, maybe in Java, Python, .NET or any language. What Hive helped us, it gave us an SQL layer so that instead of writing a code, I can write a SQL one-liner query. So basically these frameworks, right, the Hadoop ecosystem frameworks are meant to make your life simple, right? So this is all part of Hadoop, right? Yashri, Spark is also a part of your Hadoop ecosystem. Okay. Right. So we have discussed all of these, right? We have experienced instructors, we have recordings, we have online class, we have module-wise assignments, we have in-class questions. See guys, I mentioned that the recording for every session would be made available after 8 hours. This does not mean that you should not attend the session. Right? Attending the live session would be very helpful to solve your doubts, okay, which you cannot ask in a recorded session. Correct? So it's always better, it's always best to attend a live session. Right? We have project work, we have survey feedback, right? After the end of this session, you will be getting a certificate which you can verify anytime on the Edureka website. We have 24/7 support. And the best thing is we have an Android and iOS app. So these recordings, so as I mentioned, it is not downloadable, but if you're using your Android or iOS app, you can make it available offline in the app itself. You cannot download it as an MP4 file or a video file, but you can make it available just like YouTube. You can make it available offline if you're using Android or iOS. Right? This is what we have looked and what we are going to cover. So let's start with the first module, understanding big data and Hadoop. So at the end of this session, this module, you will be able to understand what big data is, right? Analyze limitations and solutions of existing data analytics architecture, understand what is Hadoop and its features. We will see Hadoop ecosystem. We will understand Hadoop 2.x core components, perform read and write in Hadoop, right? We will understand what is rack awareness, and we'll look at how to install Edureka's VM. Okay. So let's start. So what is big data? So there's a lots of hype in market, right, about big data. Right? So what do you think? What is big data? Is it a framework or what is it basically? Can I say the data which my Excel cannot handle is big data? Can I say it that way? Right? So we have multiple questions, multiple answers. Right? So Chaitanya says it's a concept. Right? That's the most appropriate answer. Right? So big data is basically a concept. Right? It's not a framework. It's not a technology. No, it's basically a concept. It's a problem statement. Right? So initially, let's say I didn't had big data. So how the data was getting stored and processed in olden days, or currently also some companies are using it. So how people store data, how people process data, they generally use a file system or a database, correct? They use database like Oracle, right? So what they used to do is all the data they used to store in Oracle, they used to process the data there itself. They used to create reports on top of these Oracle data. Okay? Now there's an issue with Oracle, right? Oracle can work very well with, say, let's consider an example. Right? So let's say I have a machine. Right? Let's say this is my machine in which I have installed Oracle. All right. Let's say this machine has a 1 TB hard disk and it has, let's say, 8 GB RAM, and it's a 4-core machine. It has 4 cores of processor. Right? Let's say I have data around, say, 20 million records. Right? Now with this configuration of 1 TB, I am able to store 20 million. And with this configuration of 4 GB, 8 GB RAM and 4-core processor, I'm able to process this data. I'm able to query this data. Right? For 20 million, everything is working very smooth. Now my data is growing at a very fast pace, right? We are living in a data age. Right? Let's say my data grows from 20 million to 200 millions. Will the same configuration suffice? Will I be able to store this 200 million of data in just 1 TB hard disk? And will I be able to process with 8 GB RAM and 4 cores of processor? Ideally, no, right? Okay, your Oracle system will get overloaded. So in this case, what you will do? If you want to store and process 200 million records, can anyone tell me what you will do for this? You can use your question pane for the answer. Right. So Chaitanya says increase the RAM. Right. So Chaitanya, increasing the RAM will help to process the data. Right. Yes. Abhilash says add additional disk. Right. So basically we need to increase the RAM also, right? The processor also, and the disk also. Right. So let's say I make my hard disk to 10 TB. Right. I make my RAM to 16 GB. And I make it a 8-core processor. Right? Now with this configuration, I'm able to store and process 200 million records. But as data hasn't stopped, data is still increasing. Right? So ultimately, what you will keep on doing? Will you keep on increasing the hardware of the system? Even if you do that, right? Even if you do that, every machine, it's ultimately a machine. Right? So what will happen is every machine has a maximum capacity, right, of the storage and the processing power it can have. Right? Every motherboard has a maximum capacity. Right? If that, we cannot increase it to unlimited, right? So if the capacity has crossed the limits, right, that's the end of Oracle. Right? We cannot process more data than the hardware and the processing power your system can take. Right? This kind of system, right? So what you're doing is you're working against a single system, right? You are powering up a single system, right? Such systems, right, are such type of configuration is called as scale up. right? Such kind of configuration is called as scale up, right? Scale means to increase, right? And up, basically you're increasing it vertically, right? You are increasing the power of a single machine. So this is also called as vertical scalability, right? Now, how big data will help in this scenario? Okay, so what big data does is, let's say again, I have a machine, right? Let's take the original configuration, 1 TB hard disk, right? 8 GB of RAM and a 4-core processor. Now this was able to store and process 20 million records, right? Now as my data has increased, right? Let's say my data has now gone from 20 million to 200 million. What solution big data provides you is, instead of powering up a single machine, right, add one more machine to your system. Right? Let's say I add one more machine with the same configuration, 1 TB hard disk, 8 GB RAM and 4-core processor. Right? Now let's say the combination of these two machines is now able to store and process this 200 million. Right? Let's say your data is still increasing. Right? What you will do in this case, instead of touching the original machines, I can add more machines to my system. Right? If 3 machines does not suffice, I can add one more machine to the system. So what you're doing here now? So you're using multiple systems here, right? With multiple systems, this kind of architecture, it's called as scale out. Right? It's also called as horizontal scalability. Right? So the big data, this problem statement, the solution to this problem statement, the first and the most important solution is using multiple machines. Right? So Hadoop, it uses multiple machines to solve your problem of data. Right? It will increase your capacity of storage also and processing also. Right? Right. Now, these multiple machines, how it is managed, how it is set up, we will look in the coming slides. Alright, so we have a question that, is this concept not possible in Oracle? Right? So yes, this is possible in Oracle. This is in Oracle, you can have multiple machines also. In terms of Oracle, this is termed as sharding. Right? We call this as sharding. Right? What the issues we face in sharding is, so there's an issue with your hardware failures. Right? So if you are sharding an Oracle cluster, it's our responsibility to look at to make it fault tolerant. Let's say in Oracle you are using 3 machines. If one of the machine fails, your entire Oracle fails. Right? The best part with big data solutions, the best part with Hadoop, it is a very, very fault tolerant system, extremely fault tolerant. It's a very intelligent system, and it's basically built-in capability of tolerating failures. That's the best part with Hadoop. Right? I hope that answers your question. All right, good. All right. So big data, it's a term for collection of data sets that so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. Right? So I have given an example of Oracle. It's a traditional data processing application. It's going on since ages. Correct? So when your data becomes very large, very complex, such traditional systems cannot store and handle it. Right? What are the challenges for having huge amount of data in Oracle? So challenges include capture. Right? See, in Oracle, it's a single machine. You're storing the data in Oracle. You're issuing queries on the same machine. Basically, you're processing also on the same machine, right? When we have lots of data, right? Let's say hundreds of people are writing data and there are millions of users using the reports, right? This simultaneous writing and reading, it will basically hang your system, right? Your entire Oracle database can go for a toss, right? So capturing this huge data, right? Storing it, searching on this, right? Sharing such huge amount of data, right? Transferring it from one system to another system. Let's say I want to take backup of Oracle into another Oracle system, right? Transferring such huge amount of data without disturbing the end users, it's a challenge, right? Then the next challenge is analysis, right? I cannot have multiple complex analysis on this data, right? See, if you have, let's say I have a system, I have 20 million records in Oracle. Even if I say select star from this table, okay, which has 20 million records, your entire Oracle can go for a toss, right? It's so complicated for Oracle to process 20 million records. Okay, so imagine you cannot do complex analysis, right, using your traditional data warehouse applications, right? The next is visualization, right? So visualization as in creating reports, right? So there are multiple reporting tools available, right? You have BI and reporting tools. You have, let's say, a tool called as Tableau, right? You have Cognos, all right? You have Pentaho. There are multiple tools available, right? So all these tools basically works with Oracle. They are triggering queries, right? Now we know, like, with such huge amount of data, the queries on a normal select star will also fail, right? So visualization also becomes a challenge. Now, what was the idea behind big data, right? What was the idea behind Hadoop? Okay, we'll take a very simple example. I'll tell you a story. Okay, so in olden days, right, where we didn't had vehicles, right? How people used to travel from one place to another? They used to take, let's say, the horse carts or bullock carts, right? So let's say I want to travel from my location A to location B, right? I used to take a bullock cart. It used to take me, say, around a week to travel. That was okay with me, right? In initial days, I had lots of time available. Okay. Now, as time flew, right, the family grew, right? So there was a couple. We have children now, right? More the family, let's say more the luggage, right? Now, when we are traveling with family, with lots of luggage from location A to location B, initially it used to take me 1 week, right? Now it is taking me 2 weeks to travel. What is the reason for this? My horse, a single horse cannot take so much of load, right? For two persons, it was okay. It took 1 week to travel the distance from A to B. With more persons, a single horse was not capable of doing it, right? So what they thought for a solution is, so what do you think? So what should be a solution for this? Should they feed lots of food to the horse and make it a powerful horse? Is that a valid thing to do? Can I grow a horse to an elephant by just feeding it? No, it's a very silly thing, right? May whatever things I give to my horse, a horse will never become an elephant. So the another solution for this was, instead of using one horse, use multiple horses, right? So instead of using one horse, now I say I use 5 horses. Now with 5 horses, I again attained the same 1 week duration for traveling with my family and the luggage from location A to location B. Now what has changed? What has changed from scenario 1 to scenario 2? So you have multiple workers now. Correct. Chaitanya says you have load sharing. Right? So what happened with load sharing is, so where a single horse was not able to share this huge amount of load, if I have multiple horses, the load is basically distributed amongst 5 horses now. It's distributed, right? Please highlight this word, distributed. Okay, the load is distributed across multiple horses, right? Same thing, same concept, right, happens with big data, right? So where in Oracle I had a single system, and as we have seen that we cannot increase the capacity of a single system up till a limit. Okay, so with Hadoop, what happened? Instead of using a single system, we now have multiple systems. So we are now distributing, right? We are distributing the load on a single system by using multiple systems together. That's a basically baseline concept of big data. Okay. Now, from where we are getting this huge amount of data? Right? So there are multiple systems. So if you take an example of just Amazon, right? Amazon handles 15 million customer clickstream user data per day to recommend products, right? So if you look at what type of analysis we can do on Amazon, right? Let's say I want to purchase a product. Okay, let's say I want to purchase a Nike shoe, right? I'll search for that shoe. What Amazon will do, okay, based on my search history, it will start recommending me other products on the same category, right? You usually see, right? People also bought this along with this, right? What's basically that? That's basically the analysis Amazon is able to do. And with such huge amount of data, imagine how many customers Amazon has, right? With such huge amount of data, handling such analysis, handling such transactions and processing it, right? That's what a big data solution can do. This cannot be attained with a traditional data warehousing systems, right? A stock market, right? It generates 1 terabyte of data per day, right? That's a huge amount of data, right? See, imagine 1 terabyte. We have hard disks in our machine of 1 terabyte, right? Imagine 30-day data would be equal to 30 computers. So imagine the storage, right? 1 TB data per day, right? It is used to perform stock trading analytics to determine trends for optimal trades. We have 294 billion, right? 294 billion emails sent every day, right? Service analyze this data to find spams. Right? You must have seen an example of Google, or let's say Yahoo, right? In every mailbox, you have a spam box available. Now, what is spam? It's basically some unidentified sources of your emails, right? Your advertisements, your promotional emails. Right? These are so some emails contains viruses also, right? So these are all spams. Okay. So analyzing this huge amount of emails and making sure that this particular information is not required, this particular information can be marked as spam, right? That can happen only with analyzing the data. It should be a very perfect solution, right? Your important mails should not go to the spam box, right? So imagine the type of analysis your Google, your Yahoo is doing. Right? Okay. Now this big data, so this concept of big data basically stands in terms of 4 V's, right? There's a concept called as 4V. All right, let's look at this concept. Right. Well, that's in the next slide. So I'll just tell you the concept. All right. Now, what is the first V of big data? Right. It stands for volume. Right. Now we have seen there's lots of, when we are saying it's a big data, then there is lots and lots of volume of data. Right. We are talking in terms of 15 million customer clicks every day. Right. We are talking in terms of terabytes of data. We're talking in terms of petabytes of data. It's very huge. Right. This huge volume of data, it's one of the characteristics of big data. That's the first V, volume. Right. The second V of big data is basically velocity. Now, what do you mean by velocity in data? Can anyone tell me what is velocity in data? So I have an answer from Rahul and Isaac. All right, so basically from most of the guys, it's basically the movement of data, the speed of data, the rate at which data is getting produced, right? The speed, yes, right? So yeah, all the answers are relevant. Right? So basically, velocity is the speed at which data is getting produced. Imagine how many guys log into Facebook every day. It's a huge number, right? Every login to Facebook, every click on Facebook generates data. Like every like you do generates data. Every comment you do, it's generating data. And imagine there are millions of people using Facebook. Right? So imagine the speed at which data is getting generated. So this is a characteristic of data which your big data have a solution to this. Right? That's your velocity. Okay, the speed of data which is getting generated. The third V is variety. Right? Now, the traditional data warehouses, it can just store and process a single type of data, that is structured data, only and only structured data. Where Oracle cannot store unstructured data. Right? So, what this big data solutions provide you is, it provides you a way of handling multiple varieties of data. Right? It can store and process structured data like your traditional data warehouses. Additionally, it can store and process unstructured data. It can store and process semi-structured data also. Right? Additionally, with this data, the types of data, it can store any format of data. Yes, Shri, you are right. It can store any format of data. So when I say variety, it can be, say, audios, it can be videos. Right? That comes as a category of unstructured data. Right? So that's a different variety of data your big data systems can support. Right? We will see what is a structured data. Right? We will see we will see example of semi-structured and unstructured. Right? So unstructured, yes, we know. Right? For example, your video, audio. Right? So Chaitanya says, can you elaborate structured versus unstructured? All right. So Chaitanya, structured data basically is a data which has a specific structure, a specific format, right? Which you can safely store inside a database. You can create a table on that data. That's a structured data, right? For example, your normal transactional systems, right? Let's say you're doing ATM withdrawals. You're having a bank account, right? The account information, it's basically a structured data, right? I'm putting some money, I'm crediting the data, it's stored as a structured data. Right? I'm withdrawing some money, that's a debit, that's stored as a structured data. So this is structured data, it has a specific fixed format. Right? When I talk about unstructured data, right? So let's say you're logged into Facebook, right? You're doing, for a particular post, you're doing some comment. Right? Now what that comment is? Does that comment has a fixed format? You can write anything. You can write from a single word to 100 lines, to 1000 lines. That's not a fixed format. It's unstructured. All right. Let's say I hit a like button. What do you think? It will create your traditional RDBMS kind of data, structured kind of a data? No, it creates unstructured data. Right? You upload photos to Facebook. You upload videos to Facebook. Right? What is all this type of data? This is all category of unstructured data. Right? I hope that answers your question, Chaitanya. Okay. Now there's one more category, semi-structured. Right? A semi-structured is actually it lies in between structured and unstructured. So semi-structured, basically it is not structured, but it has a fixed format. Okay, a typical example is your XML file. Right? So if you look at your XML file, if you look at a very high, from a very high view, it would be a normal text file. Right? You can interpret that as an unstructured data. But inside your XML file, you have fixed XML tags. All right? So basically, though it is unstructured, but it has a fixed format, right? That is a semi-structured kind of a data, right? Okay, let's go to the next slide, right? So here I was talking that we are living in a data age, right? It is estimated by the International Data Corporation that by 2020, right, the number will reach to 40,000 exabytes or 40 zettabytes of data. You know what is an exabyte? Can anyone tell me what is an exabyte? What is an exabyte of data? Exactly. So I got the answer from Bhaskar. It's 1000 petabytes. To be specific, it's 1024 petabytes. Right? So 1 exabyte is equal to roughly 1000 petabytes. So imagine 40,000 exabytes. Imagine how huge the data would be by 2020. Right? The data, the world data, it's doubling every 2 years. Right? It was based on a survey done by our International Data Corporation. Right? So by 2020, there will be 5,200 GB of data for every person on Earth. Right? That's a huge amount of data. Now, if you look at the data, at the graph which is available on the screen, if you see the data started to grow after 2005, right? What do you think? What happened in 2005? So if you look at the blue bars, that's basically unstructured data. So unstructured data started to grow 2005 onwards. What do you think? What had happened in 2005? Right? So Sandeep says and Abhilash says arrival of social media. So 2005 exactly, it was the time when Facebook went live. Right? So with Facebook, it generated data. Right? It was a time exactly, Bhaskar. Right? It was the time smartphones was used extensively. Right? The smartphones, it has lots of sensors, right? Or your GPS information, for example, right? Your Google Maps, it all works on unstructured data, right? That's so from 2005 onwards, we have a blast of unstructured data, right? And we are living in 2017. Imagine the amount of unstructured data we have now. It's very huge. Okay? And the problem with unstructured data is it cannot be processed by traditional data warehouses. You need a big data solution for this, right? The best solution considered till date is Hadoop for big data. Right. So we have a question from Godindara. Can we expect the jobs creation also as data increasing day by day? I mean related to data engineers and data scientists. Exactly. Right. So there was a survey done last year by US. Right. There are 2 lakh big data engineers less in US. Right. So there's a requirement. Right. There are lots of jobs in this big data, this entire domain. Right? There are lots of openings. Right? So there are openings for your Hadoop developers, data engineers, data scientists, right? Data analysts. There are lots of openings. All right. So this was a definition I was talking, the characteristics of data I was talking for big data, right? So we have discussed volume, we have discussed velocity, we have discussed variety, right? Now what do you mean by veracity? What do you mean by veracity of data, right? Now see, so when we are having unstructured data, there's a high possibility that we have some corrupted data as well, right? Some abnormal data as well, right? Now, when we didn't had big data solutions, this abnormal data was all ignored, right? So almost you can say there's abnormal data as noise inside your data, right? You can term this as noise, right? So almost the data which we had earlier, almost 90% of data had noise. Okay, so 90% of data was ignored, right? What happened with big data is, big data says even if we have noise in the data, there could be some part which could be important. So we should not ignore the data. We should consider, we should store, we should process that data. Okay? So the data which has abnormality, the data which has noise in the format or in the data, that's called as the veracity feature of your big data, the veracity characteristic of your big data. Right? The big data solution, it can handle veracious data also. So if you look at the example which is there, the third row, right, that is empty. Right? Your normal database, it may consider this row, it may not consider this row. Right? If you try to put data, let's say I have defined that column to be unique or that column to be not null. Right? This kind of data would be ignored by your database. Right? With Hadoop, with big data, you can safely process this kind of situations. Right? We will look how Hadoop does that. That's basically called as schema on read approach, right? Which is done by your Hadoop. Right? We will come back to this point, schema on read, in the coming slides. Right? So Hadoop big data solutions, basically it can handle veracious data with a schema on read approach. Right? Now, apart from these four characteristics, there are more V's getting added to this big data characteristics. Right? There's something called as validity. Right? Now, what is a validity? It's very close to veracity. Right? It's basically the difference in veracity and validity is, even if data is non-veracious, but if it's valid or not. Okay. For example, if we have data and it looks like data is valid or data is normal, there is no noise in the data. But how will we assume that data is correct or not? It's valid or not? That's basically when you try to process the data. That's a characteristic of big data. Okay. So we have a question from Kodanda Rao. Can you give us a best example to understand on veracity? All right. So let me think. Right. So what we'll do for this question is, we'll just park it for now and we will discuss this in the logical break. Right? Would that be fine? Right? We will discuss this in logical break. Okay. All right. So I was talking about validity. One more question. Okay. Right. So validity basically means, so though the data looks to be non-veracious, right, but it's valid or not. Right? To identify such data validity, that's also a characteristic of big data. Right? Then the next V which is added to this definition is volatility. Right? Volatility basically means how long the data is valid for. Right? Just for an example. So as I mentioned in my introduction that I'm working with data vendors with data. So there's a data vendor called as IMS. What it basically does is it provides us the physician's data, right? The prescriptions data, right? It also gives us the claims data. So whenever we receive a data set from IMS, we also receive that for how much time this data is valid for, and it's usually 1 year. Okay. After 1 year, even the data is very huge, but it is of no use. It cannot be used by us for any of our rules calculation. So there are few data sets which has a lifespan. Okay, this was just an example. So this is volatility. So even if there is huge volumes of valid non-veracious data with us, it can be valid for only a few while, right? A few years. Okay? That's a definition of big data. that's a characteristic of big data, sort of. So even if the data is non-valid, it's up to us. We can still store it. If we use traditional databases, if the data is non-valid, the best thing which we will do is we will basically delete that data. It is no more valid. But with big data, right, we can still store it. Okay, it gives us capability to have the data with us. Right? So what we'll do, guys, is we will take a logical break now. Right? So we are, as per my mentioned break time, right? It's already past that. So we'll take a 5-minute break. Right? Now here we can take your questions. So we are open for questions. I'll just do one thing. Yeah, so we are open for questions. So if you have any questions, you can ask it here. Hello. So I have a question from Abhilash that I have been hearing about data lakes. Are there mechanisms to store big data? Yes, definitely, Abhilash. Not only store big data, but also process. So it doesn't make any sense to have this huge amount of data which no one can process, right? So data lakes is basically, it provides you a platform for storing huge volumes of data, right? Additionally, to process this data, to create reports on this data, to do some machine learning or say any kind of analysis on this data. That's basically a data lake. Also, additionally, with data lakes, so we have different types of users using the lake. So once we have created the lake, this solution can be extended to different groups of users. So data lakes also keep in mind the security of data, that my data should not be visible to different users. That's also a security aspect of data lakes. Right? So if you have any other questions, you can ask me questions, or you can, if you want, you can have a sip of water, you can stretch yourself, right? You can use this as a bio break also. Okay, so I have a question from Kodandara. To perform a data scientist role, do we need to have in-depth knowledge of Hadoop development, or at an average knowledge is enough? I mean, if known the complete architecture of Hadoop flow and knowledge on components is enough. So definitely, so if you're going for a data scientist stream of this big data, I would say 20% of Hadoop knowledge would be required. I won't say you should have in-depth Hadoop knowledge. Okay, just a high-level Hadoop knowledge would be sufficient. But the important thing to go in data scientist is you should have all your statistics and mathematics concepts very clear. So there's a different stream of big data, that's data science. So there are 3 streams available in big data, basically. There is Hadoop, or there's a development role, a development stream. There's an administrator stream. The third is the data science stream. So in data science, you should know something of development and something of admin and most of your statistics thing. Right? So I have a question from Jagan. How do I start the big data journey? What use case are low-hanging fruits to try out first? Okay. So, so Jagan, so this Edureka, if you look at the assignments Edureka has provided, the best thing I found with these assignments is the use cases are very simple. Right? It's very simple, and the best thing is if you try your hands in that, Okay, if you make your hands dirty in these use cases, even if you don't have a solution, you have a platform to discuss the answers, right? You have the forums, right? You also have the solutions in the Edureka website itself, in the LMS itself. So I would suggest the best thing to start with this journey is start using your Edureka LMS for your assignments. Any other questions? All right. So I think we can start back. All right. Okay. So yeah. So I had a pending question that we wanted an example on veracity. Okay. So let's say I have I want to create an application on a specific data set. Right? What type of data? What data set I have is I have, let's say, 10 columns, right? And it has a fixed structure. Okay, it's a structured data. What I've done on this data set of 10 columns, I've written my entire logic. I've written thousands of queries, I've written hundreds of MapReduce, and I've created multiple reports. The entire workflow, let's say it's working fine for a year. What happens suddenly is, instead of getting 10 columns, I start to get 20 columns now. Right now, we know, right? The data is getting increased. The data, there are changes in data. Okay, let's say instead of 10 columns now, I now get 20 columns. Also, the initial 10 columns which I was processing, my application was processing, the ordering of the columns has changed. What will happen with this? Your entire solution will go for a toss, right? None of your queries will run. None of your MapReduce will run. None of your reports will work. So what happened in your data? Your data suddenly became abnormal. Correct? This is an example of data became pernicious. So this usually happens in big data. So just in our example, so as I mentioned, right, we have a data source, data vendor IMS. So how they provide data to us is they provide us zipped format data and they place it on Amazon cloud, right? We get the data from S3. So S3, yeah, it's basically a storage on cloud, which is a service which Amazon provides. So what IMS does is it basically gives us huge volumes of data packets every week, right? It sometimes every week, sometimes once per month. It is highly possible, like let's say for first 2-3 weeks, I was getting a fixed format of data. Suddenly, from the 6th week onwards, one of the columns in your data has gone missing. So a big data solution should be well flexible to handle this missing column solution, this missing column problem actually. Right? There's a high possibility. So when you're receiving data from third parties, right, it's a high possibility that they may change the format of data. This kind of data is basically veracious. Data format can change. Right? Sometimes some rows can also go missing. Okay? So this is an example of veracious data. Right? So I hope that answers the question. An example of veracity. So I have a question from Shri. Can you explain the chart? Which chart, Shri? It's not basically a chart, Shri. It's basically a table, all right, which is saying that suddenly I was getting data in some rows. Suddenly some data gone missing. Okay? This is basically an example of veracious data. But initially I was having some data, and suddenly some of the rows have gone missing. Right? Okay. Right. So this is Annie, right? So we would be having some quizzes in while we are doing the sessions. So we would be having some Annie questions, right? Let's make it interactive. Right? Okay, so map the following to corresponding data types. So what do you think? XML files and email body. What type of data it is? It is structured, unstructured, or semi-structured? Right. So Minesh says it is unstructured, and rest of everyone says it is semi-structured. Right. So the answer is this is semi-structured data. So as I mentioned, right, XML, though it looks unstructured, but it has a fixed format. Right? And if you talk about email body, it has a fixed format, right? Your email contains, it has a fixed format. Like you have a subject, you have an attendee list, you have a body, you have a fixed format to your emails, right? So these are semi-structured. What about audio, video, images, archive documents? Simple, right? It's unstructured, exactly. So all this is unstructured data. What about data from enterprise systems? Right, your ERP, SRMs? Yes, exactly. These are structured data. Interesting. Right, so XML, semi-structured. Your other data is unstructured, and ERP systems, CRM systems, these are structured. Right? You can read further on big data by referring to these sites. Right? Okay, these are some common big data scenarios. Right? So, for example, I've given you my scenario, like I'm working with the data vendor IMS. There are multiple scenarios in which big data can be used. Right? For example, it can be used for web and e-tailing. Just a use case, eBay. Right? eBay has recommendation engines. So if you're searching for a product, the next time when you log into eBay, it will start recommending you that based on your previous history, this is what you may be interested in. So you must have seen, right? You may be interested in this section is always there in such websites, your eBay or Flipkart, Amazon. So this is basically it's a big data scenario. It's basically tracking your user history, and based on your pattern of searches, it is tracking that data, storing that data, analyzing it, and creating recommendations. It is used for ad targeting. Let's say I want to purchase something, and I'm trying to find the reviews of that product from Google. Let's say I want to purchase a cell phone. Okay, I usually my practice of purchasing any gadget is I usually look at the reviews first. Usually most of the people now is doing the same thing. You usually go to Google, find the reviews. You haven't yet logged into Amazon, or you haven't yet logged into any social network. You're just finding the reviews. The next time when you log into any website and let's say eBay or let's say Facebook also, you will notice a small advertisement, right? You will notice a small advertisement saying this is the price of the product, these many offers are available, these are the discounts available. Now the question is, you haven't went for searching the price of that product. How are you getting that ad? This is basically termed as ad targeting. Based on your search patterns, based on your browsing history, such websites can use your data and can do some ad targeting. And how do they get this data? This is basically from your browsers. So what do you think? Chrome, Google Chrome, for example, it's a very excellent browser, right? How can Google afford to sell this Google Chrome for free? It's basically not free. So what Google Chrome does is the data which the browsing whatever you're browsing on Google Chrome, the data which they are capturing, they're selling your data. Right? They're selling your data to companies like eBay. And what eBay does with this data, it does this ad targeting and recommendations. So though you seem to be a free user of that system, but you are actually a product, right? You become product for Google Chrome. Okay, and search quality, right? Based on multiple user search history and other patterns, the quality of search will go on increasing as the data goes on increasing. So with less data, my search quality can be so-so, right? But as I get more and more data, I can be confident that my algorithm for recommending or for ad targeting will work best. That's the search quality which will happen with when your data increases. Right? It can be used for the fraud detection also. Okay? Then there's a customer scenario. There's a use case for China Mobile. Right? They use the customer data for your churn prevention. Right? Now, what do you mean by churn prevention? So basically, lots of people, they use they use a mobile company, let's say for 6 months, and then they leave, and they don't disconnect the connection, but they stop using it, or they throw the SIM cards away. So what happened is that customer got churned. Now, with this huge amount of data, right, what telecommunication industry usually does is it looks the pattern of your calling, like it looks the pattern of your how are you using the services of that company. Like if you're satisfied with the services, okay, and or if you're dissatisfied. If you're dissatisfied, there's a high possibility that you may get churned. So what China Mobile did is, based on the data based on the previous data for dissatisfied customers, they started collecting feedbacks from them. Right? They started collecting feedbacks. They started giving more and more facilities, more and more services to those customers just to prevent churns. A typical example, like in India, Airtel is doing this. Right? For example, for a particular location, I'm not getting my Airtel network. So what? So lots of people in that particular area had stopped using Airtel and they're shifting to other companies like Idea or let's say Vodafone. So what Airtel did in this case is it identified based on the customer satisfaction or dissatisfaction that this particular area does not have network. So what, as a feedback, what Airtel did, it launched more towers in that particular area. This is all based on the data pattern, the data history. Right? These things cannot be done without data. Right? It can optimize your network performance. It can optimize your so all of this can happen based on your data record analysis. Right? It can also predict network failures. Right? Then who else is using big data? Right? Government. Everyone must be knowing UID, right? Aadhaar. So Aadhaar card. So if you see what type of data Aadhaar card is storing, it is storing all your biometrics data, right? It is storing all your personal information, your address details, your ID details, right? Your fingerprints, your retina scan. Now, is this data structured? Your retina scan, it's an image. It's not. It's definitely non-structured. Now what Aadhaar is doing is all this information. So imagine the amount of people we have in India. So everyone having their own Aadhaar card and everyone has their own data. So Aadhaar, it's basically using big data. It's basically using a Hadoop framework, your Hadoop cluster to store the entire Aadhaar information. Right? Just to be specific, Aadhaar is built on HBase. All your Aadhaar card information, your customer information, user information is stored in HBase. And they're using a map-R distribution of Hadoop cluster. A map-R distribution. We'll discuss about Hadoop distributions in the coming slides. It's just a additional information. Right? Then it can be used for health science and life care and life sciences also. Okay, just an example which I shared. Right? It can be used for your drug manufacturing, your health information, gene sequencing, right? Your drug safety. All this data, all this can be used for your healthcare and life sciences use cases. Right? It can be used in banks. Right? It can be used to model your true risk. Right? With such huge amount of data, it can basically predict that there can be a threat or not. Right? It can predict frauds. Right? It can be used for credit scoring and analysis. Okay? It can be used for trade surveillance. So this is all use cases of big data. Right? A very good example is for retail outlets. Right? There's a retail outlet in US, Sears. It's very similar to Walmart. Right? Or it's in India, it's very similar to a big bazaar. So what Sears does is it has lots of data based on your what are you purchasing from Sears. Okay, it can be an electronic thing or any gadget or anything. Okay, this huge amount of data, they use it for the churn analysis. They also use it for sentiment analysis. Now, what is sentiment analysis? It's the thing which I was talking, the reviews. If it's a bad review, you usually don't go and purchase that product. Right? If it's a good review, it's a high tendency that the customer will go and purchase it. So these reviews are basically nothing but the sentiments of the customer. Right? So based on the sentiment analysis and additional information, there is a website. Okay, there's a website which basically does the sentiment analysis for you. Right? I'll just name the web. I'll just give you the link of that website. It's very helpful. It's just for additional information. You can just go and have a look. Right? It's www.socialmention.com. www.socialmention.com. It's basically like a search engine, very similar to Google. But the best thing is it is connected to multiple social networks. It is connected to Facebook. It is connected to Yahoo. It is connected to Bing. Everything. There are more than 15 social networks it is connected to. So whenever you are searching for anything, apart from the results, it will also give you the sentiments of that particular topic you searched. Right? It's a very interesting thing. It's all working on big data. Right? It will be very interesting. Just go and use it sometime. See, maybe not. Don't do it now. After the sessions. Okay. So this is a use case, a detailed use case of Sears. Right? So what Sears was doing earlier, the same thing which we were doing, the same project which I had worked on, not in Sears but in my organization. So Sears was initially using Teradata, Oracle, and SAS for storing all the customer information, processing it, and creating reports. Now Sears identified that as the demand of products have increased, as big data has stepped in, as the unstructured data has increased, for example, this customer sentiments and comments and reviews, they identified using this traditional data warehousing system, it will not work for them. So what Sears did, they migrated to Hadoop. Okay, the same kind of use case I had worked on. Right, that was my first big data project. So we also migrated from Teradata to Hadoop. What's the advantages you're getting here? You're able to now store big data. You're able to now process big data. Right? You are able to process the huge amount of data which was initially left ignored. So this slide talk about the limitations of existing data analytics architecture, right? So if you see, you had, give me a second. Okay. So initially, if you see, you had all your storage grid together, right? So if you had huge amount of data, it used to get stored inside a huge infrastructure where it only used to store data, right? If you wanted to process something on this huge amount of data, what you need to do is you had separate compute grids, right? Grid is nothing but a huge set of machines. So basically, initially, storage was separate. If you want to process this data, you had a separate infrastructure setup to process it. Now for processing, you require data. So what you used to do, we used to transfer data from storage grid to processing grid. Now when you're transferring this huge amount of data, here comes the limitation, right? You cannot move such huge amount of data, right? Your network, your machines, it cannot scale up for storing and computing such huge amount of raw data. So what used to happen is, out of the entire data, only 10% used to get computed. The remaining 90% were just archived and kept at, it was just archived. It was not used for analysis. Right? Just an example. So a meager of 10% of approximately 2 petabytes of data was available for BI. So if I had 2 petabytes of data stored in the storage grid, only 10% was used for your business intelligence, right? The remaining 90% of your data was just getting archived and it was not used, right? What was the reason for this? The reason was we didn't had so much huge computing power for processing this 2 petabytes of data, right? Now what changed with Hadoop? Right? What Hadoop did in this case is, instead of keeping the grid separate, it basically clubbed the compute grid with storage. Right? Now the grid which is using your storage, the same grid can now process. That is what the power Hadoop had got. Right? So that's discussed in the next slide. So what Hadoop did now is, the storage and compute is now combined. Right? By combining the storage and compute, what happened is, now there is no more requirement of moving data here to there. Right? When you are not moving data, means you are not using network. Correct? If you are not using network, let's say I have 2 petabytes of data. I want to transfer it from machine A to machine B, or not a machine, 2 petabytes cannot be stored on a machine. Let's say I want to transfer it from storage grid A to storage grid B. Imagine the time it would take to transfer 2 petabytes of data. What is the usual transfer rate of network we have? It can, for a best experience, 100 GB is the best network which we can use, 100 Gbps. Right? Imagine transferring 2 petabytes. That's equivalent to 2048 terabytes of data on a network with 100 Gbps of speed. It will take days to transfer. Right? This was the reason this entire 2 petabytes, only 10% was transferred and processed. But now with Hadoop, we are not transferring data anymore. Right? The data which is there on your storage grid, it's there in the storage grid itself. In fact, the computing power comes locally there and it processes the data locally. So you're not using network. This is the power Hadoop had brought in. So with this power of Hadoop, you're now able to process the entire 2 petabytes of data. You're not processing just 10%, you're processing entire 100% of data. And your data is alive, you're not archiving it. Okay. Any doubts in this? See, if there are no doubts, so either you are understanding everything or you are understanding nothing. Right? So there should be questions. So if I was a student, I would have a question like how Hadoop is doing it. What is special about Hadoop? How Hadoop can handle? Okay. So I have a comment from Rahul that Hadoop is distributed system. It requires network, right? Yes, Rahul, it requires network, but it's a very intelligent system, right? It tries to use the network as less as possible, right? So I'll discuss this when we'll look at the architecture of Hadoop. Okay, so Jayesh says adding compute grid will slow the performance of storage systems. Right, Jayesh, but it is handled very specially with Hadoop. So if I'm combining my compute and storage grids with Hadoop, it won't matter a lot, right? It won't matter on the performance of storage, right? This will also be very clear when we look at the Hadoop architecture. Right? Now this is the idea behind Hadoop, right? Now what Hadoop does basically is so I have a question from Chaitanya. Can you explain compute grid in Oracle? So Chaitanya, this sounds to be a irrelevant question for now. So let's park this. So compute grid in Oracle is basically on the same machine, right, where you're storing it. Same machine is used for processing it. You don't have any special compute grids for Oracle, right? That's all. If you want additional compute grid, you install a set of machines additionally on which you point all your reporting and all your queries. So basically you install a huge server, right? That server will transfer data from your storage to your compute grid and then process it. The same which we have seen in the first slide. I'll give you an example, or we'll start discussing on Hadoop now. Okay? Now this Hadoop, okay, it's basically a framework, right? It's a framework which is written in Java, right? And it is not a single framework. It's actually a combination of two different frameworks, right? The first framework, it is used for storage, right? And the second framework, it is used for processing. Right? So it's actually a combination of two separate frameworks. Right? Hadoop was developed in 2006 by a person called as Duff Cutting. What Duff Cutting did is he very smartly clubbed the storage and the processing into a single system, and there it was. Hadoop was developed. Now what is storage? What is processing? Why these are separate frameworks? Right? Now, as I mentioned, it's a big data solution, so it works with multiple machines. Okay, so let's discuss about storage first. What happens in storage? Okay. Now the storage. So as I mentioned, there are multiple machines. Okay. Now when there are multiple machines, right? How will I? So it's used for storage, right? Let's say I have 10 machines, and let's say I have a 1 GB file which I want to write. How will I know to which machine I should go and write my 1 GB file? I have 10 machines, correct? So it's very difficult for me to know which machine to go and write to, right? To make it simple, right? What Hadoop did is it is following a specific architecture, right? The architecture with which Hadoop uses, it's basically a master and slave architecture. Right? So out of the 10 machines which you have, one machine becomes the master, right? And the remaining machines, it can be multiple. Remaining machines becomes the slaves, right? And all these machines are connected through network, right? Now these all machines, these 4 machines, this forms my storage framework. Okay? This forms my storage architecture. Now basically Hadoop is very misconcepted as a database, right? Hadoop, it is not a database, right? Just get that very clear. Hadoop is not a database. It is basically a file system, right? Hadoop is a file system, right? Basically the storage part of Hadoop I'm talking about, right? Now when I say I have 4 machines here, does that mean I have 4 file systems here, or it's a single file system? Right? Any answers? If I'm having 4 machines, is it a single file system or it's 4 file systems? Right? So Rahul says it's 4. Shri and Jaya says it's a single file system. Right? Yes. Most of the participants says it's a single file system. Okay. So the right answer to this is it's a single file system. Right? The right answer to this is it's a single file system. Okay. So if I have 4 machines, right, this is basically sharing, right? It is sharing a single file system. Now how we usually share? It's through network, right? So it's a network shared file system. Now anything which is shared across network, it is called as distributed. Anything which is shared across network is called as distributed. So as I mentioned, Hadoop is a file system and it is distributed, right? And it's for Hadoop, right? So it's a Hadoop distributed file system, and that's what the abbreviation HDFS, right? So HDFS stands for Hadoop distributed file system. Okay, so it's basically a combination of multiple machines tied together, sharing a single file system across network and tied by a master and slave architecture. Right? Getting this point? Okay. Now the same question. Now I have 4 machines. Right? Let's say each machine has a 1 TB hard disk. Right? Each machine has a 1 TB hard disk. I'm not talking about the RAM and processor here because I'm just dealing with storage. Okay. Now I have a file. Let's say f1.txt. Right? It is a 1 GB file. Now if I want to write this file to my HDFS, it's a 4 machine. Now how will I know to which machine should I go to? Should I go to the master? Should I go to slave 1, slave 2, or slave 3? How will I know this? So she says you have to go to the master, and Sandeep says S1. Okay. Jayesh also says always the master. Let the master decide. Okay. So most of us are on track. It's actually the master. That is why Hadoop is following the master slave architecture. Right? So though HDFS in the current paint looks like 4 machines, but for us, for developers, HDFS is a single machine, and that single machine is nothing but your master. Right? So internally, though there be 3 slaves, or though there are 100 slaves or thousands of slaves, right? It doesn't matter to the developers. That's actually an administrative part. To set up these machines, to make it a part of Hadoop cluster, that is what your Hadoop admins does. That's basically comes under your infrastructure. Okay? For developers, for using your Hadoop to store and retrieve files, it's just a single machine for you, and that single machine is your master. Right? Just an additional information. Right? Your Yahoo, it has a test cluster, a test Hadoop cluster with 40,000 slaves. Right? 40,000 slaves. Okay, so Bhaskar has a question. F1.txt gets stored in all the 3 slaves or one of the slaves, right? So Bhaskar, I'm coming to that, right? That's the next thing I'm discussing. Okay, so what I'll be doing is I'll be storing this f1.txt. I'll be giving this file to my master. Right? Now, as I mentioned, each machine is a 1 TB hard disk. What will happen if my file.txt is not of 1 GB but it is of 2 TBs? What will happen in this case? Will this file be accepted? Because as I'm giving this file to my master has 1 TB hard disk, but my file size is 2 TBs. Will this be accepted or not? Okay. So Sandeep says no. Okay. All right. So I'll discuss what most of the answers I'm getting. So I'll tell you what Hadoop does. So it's a very smart system, right? It's a very, very intelligent system. Okay. So what basically Hadoop does is what your master does, right? Whenever you give a file to your master, right? I'm considering an example of 1 GB. Whenever you are giving a file to your master, out of this 1 GB, your master will store nothing at all, right? Your master will store nothing at all. What your master will do, it will break your file into pieces, right? It will break your file into chunks, right? The size of chunk is fixed, right? It is 128 MB, right? It will break your file into chunks of 128 MB, right? Now this chunk can be controlled. By default, it is 128 MB. In Hadoop 1, it was 64 MB, right? It can be controlled. It is configurable. See, almost 99% of the configurations in Hadoop, the properties in Hadoop are configurable. Right? I'll come to this point later. It's too early to discuss that, right? So what Hadoop will do, it will break this 1 GB file into chunks of 128 MB. So for 1 GB, how many blocks would be there? How many chunks would be there? Ideally, there would be 8 chunks, right? 8 into 128 makes it 1 GB. These 8 chunks, your master, right? It will distribute across network to your slaves. Now, in the current diagram, I have 3 slaves. Now, to which slave these blocks will go to, right? Now, this is something which we cannot control. It is the master who will decide which block or which chunk goes to which slave, right? Let's assume, right? Let's assume out of 8 blocks, 4 blocks goes to my slave 1, 2 blocks goes here, and 2 blocks goes here. It can be anyhow, right? It can be anyhow. It's your master who decides it, right? And we will never know what your master has decided. Okay, we will never know that 4 blocks are on slave 1. We will never know that. It's all internal. Only your master will know it. Okay? So this is what happens in storage. Now, when you try to retrieve the file back, right? Let's say I want to read the file. Again, for us, HDFS is a single system. That's the master. So I will read the file from the master itself. So I read the file from the master itself. I have a question. Okay, so Bhaskar says, what do you mean by only master knows? Can't we find out by reading the master? Yes, Bhaskar, we can. So your master basically stores what block goes where. So we can retrieve that information, right? But ideally, that information is not created by us. That information is created by the master. That's why I said only master knows it. Right? You can query the master. You can check what master has created. You can check that. Right? Okay. All right. So when I try to retrieve the file back, what your master will do, it will give the locations to the client that my 4 blocks are stored on slave 1, my 2 blocks are stored on slave 2, and my 3 blocks are stored on slave 3. Your data, master will read from all the slaves and give it back to you. This is how your file would be read back. This is how your read and write operations happen on your HDFS. Alright. Now when we are dealing with multiple machines, right? In big data solution, we are dealing with multiple machines, right? What can anyone tell me? What are the two important resources in any distributed system? What are the two important sources in any distributed system? So Simon says load balance. That can be a characteristic side. Fault tolerance. So you're talking about the characteristics. I'm not asking about characteristics of how this is handled. Right? I'm talking about what are the two major important resources, right, which is used in any distributed system. Bullseye. So Kishore got it right. Right? The first one is network. Right? So Kishore got it right. The network. Yes, Jayesh. It is network. Right? So the first important resource in any distributed system is network. Without network, you cannot call it as a distributed system, right? So if I remove network from these four systems, these would be four separate systems. These won't be connected. This won't be distributed, right? So without network, I cannot call a system to be distributed. So the first most important resource is network. The second most important resource I will mention, it is the hardware, the machine, right? So I am having four machines here. So these are the important resource in a cluster, right? The machines and the network makes it a cluster, right? Now machines, right? It's a hardware, right? Machines tends to fail. Okay, let's say while reading the file back, one of my machine fails. Let's say my machine S2, this fails. Will I be able to read the entire file back? Okay, so out of my 8 blocks, right, 2 blocks which were stored on my slave 2, these are lost. Right? So ideally, right, Jayesh and she says it that we cannot read it. Right? We won't be able to read it. Okay. Now we have a question, we have an answer from Kodanda Rao that yes, we can. Right? Now how that is possible? So I'll give you the right answer. Yes, we can. Right? So Hadoop, as mentioned, it's a very excellent system and it has built-in fault tolerance. Right? Now how it is possible? Right? What makes it different for Hadoop that it can read the file back even the machine has failed? Right? Now there's something in Hadoop called as replication. Right? In Hadoop, it's something called as replication. Now what? And Hadoop, this HDFS has a default replication with a factor of 3. Right? Hadoop has a default replication factor as 3. Now what do you mean by replication? Right? It means that how many blocks Hadoop is storing, it would be multiplied 3 times. Right? This means Hadoop will not store this 1 GB file as 8 blocks. It will store it as 8 into 3, that's 24 blocks. This also means your 1 GB file would not be stored as 1 GB. It would be stored as 3 GBs. Right? So HDFS, it is also known as a redundant file system. Right? Your HDFS is also called as a redundant file system. Right? Now the next point will answer your question, Bhaskar. So Bhaskar has a question. The replication is stored into the same slave. Yes, I'll answer the question. Okay. Okay. So So each block is replicated thrice. So let's say on the slave 1, where I have 4 blocks, let's consider the first block. Let's say the first block out of these 4 is BLK_1, for example. Right? Now with Hadoop, with replication, this BLK underscore 1 will have 2 more copies, exact duplicate copies, right? Hadoop, it guarantees you, right? HDFS guarantees you, listen to the statement carefully, right? The replicated block for a single block will never be stored on the same slave, right? The replica of a block will never be stored on the same slave. It will be stored on separate slaves, right? So the replica on block 1 would be stored on slave 2 and slave 3 because we don't have any other machine left, right? We have only 3 machines and the replication factor is 3, right? So the replica of block 1 would be stored on slave 2 and slave 3. This means these 4 blocks of slave 1 would be available on slave 2 also, slave 3 also, right? These blocks, 2 blocks of slave 2 would be available on 1 also, 3 also, and these 2 blocks of slave 3 would be available on 1 also, 2 also, right? Now in this case, right, in the case of failure, let's say our machine 2 has failed. These 2 replicas which were stored on machine 2, the slave 2, it is available on slave 1 and slave 3. Your master, right, your Hadoop HDFS master is so intelligent that it will notice that the machine has failed. It is not able to read that file back. It will read it from slave 1 and slave 3. Right? The best thing is it is transparent to the user, right? Your end user, your clients won't even know that the machine has failed, that one of the slave was not working, right? It would be transparent to the user. That's the best, that's the beauty of Hadoop. Right? Now there are few things like what will happen if your master fails, right? What happens if your master slave fails? We will see that that's the question if that's the question in your module 3. Okay, 2 or 3, I guess, HDFS. Right. So Abhilash asks, what if S3 is down 2? Right. So even S3 is down, Abhilash, so S3's 2 blocks is available on S1 also, right? So 2 blocks of S2 is available on S1 and S3. 2 blocks of S3 is available on S1 and S2. Right. So ideally, every machine has the entire file bank. Every machine has 8 blocks. Okay. This is true in this case because we have 3 machines and the replication is 3. Right. This would not be true if we have 100 machines and the replication is 3. Right. Maximum copies would be 3, not 100. Right. Okay. Now, why distributed file system? Right? Now, the best beauty of using multiple file system is, so it's based, how your data is stored. It is stored where your data is stored. It is stored into your hard disk. Right? Now, when you're reading data from hard disk has some features. It has 4 channels, and each channel in the latest hard disk has about a speed of 100 Mbps. Right? For the latest hard disk, which are called as SSD hard disk, solid state devices, the speed is more. Okay, but if you consider normal regular hard disk, it can read up to 400 Mbps because it has 4 channels. Right? Let's say if you have 1 TB of data, right, and if you're trying to read 1 TB data from a single hard disk, how much time it will take with 400 Mbps of transfer rate? Okay, if you do a calculation, it will take around 43 minutes. Right? What happens with the distributed file system is, so remember I have shown 3 systems, these 3 slaves, right? What's the beauty of this 3 slaves? It is giving you fault tolerance because even if machine is failed, I can read the data back. Additionally, what feature, what capacity it is giving you, you can read from all the 3 machines simultaneously, parallelly. Right? So distributed file system gives you a beauty of parallelly reading your data. Okay, so Sandeep has a question: if the file is cloned in all the slave system, how it will solve network constraints? Right? So Sandeep, I'll discuss this when we will discuss module 2, that's your HDFS. All right. Just to give you a small quick answer for this, Hadoop is very slow in writing. Okay, so if you're cloning it, it will use network and it will be slow in writing. Hadoop is very fast in reading files. Right? So it's very slow in writing and it's very fast in reading. Okay? The details is yet to come in the module 2. That's scheduled for tomorrow. Okay. All right. Now the same 1 TB data, if you try to read from 10 machines parallelly, right, your time would be reduced by 1/10. Right. So the data which was earlier read in 43 minutes can now be read under 4.3 minutes. Right. That's why we use distributed system, multiple machines. Right. So Apache, so what is Hadoop? Right. So overall I have discussed what is Hadoop. We'll just read through it. So Hadoop is a framework that allows for distributed processing of large data sets across clusters of commodity computer using a simple programming model. Right. Now Hadoop is very famous. Okay, it's a very famous commercial tool available till date. Right. What makes it famous? Right? There are multiple features of Hadoop. Right. The first and the very basic reason which made Hadoop famous is Hadoop is free. Right? It's said that it's the best available software free of cost. That makes Hadoop really very famous. The second thing which makes Hadoop famous is it works on commodity hardware. Now, what do you mean by commodity hardware is commodity means commonly available hardware. Right? Like a normal 8 GB RAM quad-core processor, it's a commonly available hardware. Hadoop can very smoothly work with commonly available hardware. So if you have 10 machines, each machine has a commonly available hardware, Hadoop will still work will work very smoothly. Okay? As compared to other systems. So there are other big data solutions also. Okay? I'll just give you an example. There's an analytical database called as Netezza. It is a product of IBM. Right? It can process, store, analyze huge volumes of data. It is meant for storing and processing big data. Okay? But it has a issue. It has a problem. The machine is very expensive. Right? It takes millions of dollars, right, just for increasing the capacity of the machine. That the best part with Hadoop is it can give you the same performance as Netezza, but on commonly available hardware. That's the best thing with Hadoop. Okay. All right. Okay. So key characteristics. Okay, it is reliable, it is flexible, right? It is economical, and it is scalable. Right? Scalable as in let's say I have 3 machines, 1 TB each, which can take maximum of 3 TB of data. If I have more data, what I will simply do, I will simply add more slaves to my system. Right? So it's very flexible to scale. Right? It is very reliable. It has inbuilt fault tolerance. If your machines are failing, the data is still available. Right? It is economical because it works on commodity hardware. So guys, let's take a energy break now. Okay, around 7 to 10 minutes of energy break. Okay, so I'll just set up a timer. So I'll just set it up for 7 minutes, but yeah, 7 to 10 minutes should be fine. Okay. So see you guys in 10 minutes. Right? Please be back on time. Hi guys, I'm back. So everyone is here. All right, guys. Let's resume back. Okay. Now, design principles for Hadoop. Now, Hadoop facilitates the storage and processing of large or rapidly growing data sets. Okay. So, as I mentioned that yes, Hadoop is a big data solution. So, large, that's a big data characteristic, right? Volume, or rapidly growing data set. That's a big data property again, right? The velocity. It can store and process structured and unstructured data, and it's a simple programming model. All right. So we have also discussed that it is scale out rather than scale up. Correct? So Hadoop, it's a horizontally scalable system. Instead of giving power to a single machine, we use multiple machines instead. Okay. Now it brings code to data rather than data to code. All right. So let's discuss this point. Now the things which so as I mentioned that Hadoop is actually a combination of two different frameworks, right? We have seen the HDFS part of it, the storage part of it. Okay. One thing I can safely say it now. In Hadoop nomenclature, in Hadoop terminology, the HDFS master, right? The HDFS master, it is called as name node. Right? In Hadoop terms, the master which I was showing you, which was reading and writing my data, that's called as a name node, and the slaves, there can be multiple slaves, those are called as data nodes. So I can have only and only one name node, and I can have a huge number of data nodes. Okay. Now let's discuss about the processing part of it. Right? Again, processing, as I mentioned, it is a separate framework. Right? This framework also works in multiple machines. Again, if it's working in multiple machines, it should follow an architecture, and it follows the same architecture like your HDFS, the master and slave architecture. Okay, the processing framework of Hadoop, that's called as MapReduce. Again, in MapReduce, you have a master and you have multiple slaves. I usually have a habit of drawing 3 slaves, keeping in mind the replication factor. Okay. So this is your master, and this is your MapReduce slave. Right? Now, just to name it, the MapReduce master, it is called as resource manager. The MapReduce master is called as resource manager. Sorry for my handwriting. The slaves are called as node managers. Right? Node manager. Right? The slaves are called as node managers. Okay. So this is a typical architecture of your MapReduce. Okay. Now in MapReduce, what are we trying to process? We are trying to process the data, correct? Now where is the data? In Hadoop, where is the data? Any quick answers? Maybe Kishore can answer. Where is the data? Okay, so I have an answer from Rahul. Data node. Abhilash says the file system. Yeah, but to be specific, it's the data node of your file system. Okay, so data is on data node. That's your HDFS. Okay, now MapReduce will process the data which is there on data node. Okay, this means like your node managers, like basically your MapReduce slaves. See, what are these? What is a resource manager? What is a node manager? What is name node? What is data node? These are basically Java processes. So Hadoop is Hadoop is written in Java, right? So these are nothing but Java daemons, Java processes. Okay. When I say this particular machine is a resource manager, this means this is a normal machine in which I have installed Hadoop and I'm starting my resource manager process. When I say this machine is a node manager 1, this means it's a normal machine. I have installed Hadoop and I have started the node manager process. So it's basically Java process. Okay. Now in MapReduce, so how this MapReduce and HDFS is coupled? It's coupled basically on your slaves. Okay. So this means your slaves, like your MapReduce slave, which is node manager, and your HDFS slave, which is your data node, should sit on the same machine. Okay, so every slave should have a node manager plus a data node. Every machine should have a node manager plus a data node. Now, why is this? Because in MapReduce, so there's a separate module for MapReduce. Just to give you an idea, in MapReduce, what you do is you write a code. Okay, code in any language, Java, Python, .NET, C#, any language. Okay, you package that code, and similarly like HDFS, you're dealing with only master. In MapReduce, also you deal with master. You submit your processing code to your master. Now you're processing a file, right? You will also specify which file you want to process. Okay, so I have a question from Bhaskar that only MapReduce can process the HDFS data. So till Hadoop 1, Bhaskar, it was only and only MapReduce. Hadoop 2 onwards, it has different frameworks which can process your data. Okay, so Bhaskar says, because you said name node must exist on the slave along with data. Bhaskar, just don't get confused. It's not name node, it's your node manager. I just write it down. It's not name node, it's your MapReduce slave. That's your node manager. Right? The abbreviation may confuse, right? NM, it's node manager. Okay. We will see how Spark can process it. There are other frameworks. We will see how Impala, there's something called as Impala, how Impala will process it in the coming sessions. But for now, as the architecture which I have shown on this diagram, for this only MapReduce can process it for now. Okay. All right. Okay. Now for processing your data, what you do is you write a MapReduce code. You will submit it to your master. Now you are processing a file, so you will also specify the path of your file. Okay. I'll say that I want to process it on my file.txt. Right? What your master does, or what your resource manager does, it contacts your name node. Right? It contacts your name node. It asks your name node basically that I want to process this file.txt. Please let me know where are the blocks of this file kept. On which data nodes will I find the blocks of this particular file.txt. Your name node will say that 8 blocks are on data node 1, 2 blocks are on data node 2, 2 blocks are on data node 3. Resource manager will say, okay, so what I will do is, instead of, okay, so tell me one thing. Let's say you want to process something. Let's say you want to process a file. In traditional way, let's forget about Hadoop. In traditional way, how will you process it? You will write a piece of code, right? You will run that piece of code, and to that code, you will pass the file as an input. Correct? Is this how you process a file in normal Java or Python or .NET? You will write a code to process the file, and you will pass that file as input to your code. Right? This is normally we follow. Hadoop, it is other way around. Okay. Why it is other way around? So as mentioned, right, network is a very important resource in any distributed framework. So it pays that you try to use the network as less as possible. Hadoop tries to do the same thing. Okay. Now your files, which is distributed in blocks, you can have multiple blocks, right? For this case, I have 8 blocks. Oh, sorry, I just wrote it wrong. Right? This should be 4. Okay. All right. So for this particular scenario, I have 8 blocks, 4 on node 1, 2 on node 2, and 2 on node 3. Okay. If I write a code, and if I say I want to pass this file to the input of my code, if I run my code at my master, what will happen is my code is running here. I need to pass this all data to my code. Basically, I need to transfer all this 8 blocks across network to a single machine, which is your resource manager, to process this data. Now, what will be the issues here? If you notice, the network of the master, it will get jammed. Correct? Because 1 GB is getting transferred across the same network link. Right? Also, it will take a lot of network to transfer blocks of 128 MB. Okay. Now, if you want to process this file, let's say you write a very simple algorithm to count how many number of lines are there in my file. Very simplest algorithm. What would be the size of your code? Let's say you write it in Java, or let's say any language, Python, .NET, any language. Will your code size grow more than 2 MB, 2 MB or 3 MB? Correct? It won't be more than that. What is a code? It's just a normal text file, right? So your code, it won't grow more than 2 to 3 MB. Let's assume the very extreme case, 5 MB. What is the size of your data? Each block is 128 MB. So which one is faster, transferring 128 MB across network or transferring 5 MB across network? Obviously 5 MB, correct? So what Hadoop does is, instead of giving data to your code, listen to the statement carefully. Okay? Instead of giving data to your code, it says the data where it is kept, let it be there. I will go there and process the data. Right? So instead of giving data to your code, it gives code to your data. So this 4 blocks which are there on your data node 1 would be there itself. It would be processed on that same machine itself. These 2 blocks of data node 2 would be processed on that same machine itself. Right. So I have a question from Abhilash. When name node returns the block distribution to resource manager, how does it know with which block to begin with? Right. So this is something we will get a clear understanding in when we look at module 3 map reduce. But to give you a clear idea, just to give you a short answer to this, all the blocks are processed independently. Right? So it doesn't, so we are working in a parallel, so MapReduce, it's a massively parallel framework. Okay, so ideally what will happen is all the 8 blocks will start getting processed parallelly all together. So there's no sequencing point here at which block should start first. See, ideally I need to count number of lines. So it doesn't matter if I start with block 2 first or block 1 first or block 7 first. The main logic here should be all the lines combined should give me the answer. All the blocks lines combined should give me the answer. So the sequencing is not important for this. Okay? So what happens in MapReduce is, so these 4 blocks which is there on your slave 1 would be processed there itself. For processing, it's a MapReduce thing. For MapReduce, the MapReduce slave will process. MapReduce slave is your node manager. To process the data locally, right, this is the reason your node manager should also have a data node running. So this 4 blocks would be processed by the node manager of the same machine locally. These 2 blocks of the same data node will be processed by the same machine's node manager locally. Similarly, in this case, right, the output of all these 8 blocks would then be merged and you will get the final output. Right? Every block's output would be merged. That's called as reduce in MapReduce. Right? That's the reduce phase of MapReduce. We'll discuss that. Okay? I'm just giving you an idea. So the idea is it is sending code to your data because for processing, if you notice, it is not using network. Right? For processing, it does not require network. Right? So I have a question from Bhaskar that output would be reduced in resource manager. I'll just give you a short answer for this, Bhaskar. The answer is no. Output would be reduced in the slave itself. That's your node manager itself. So there's a reduced task which will run in your node manager. So I'll discuss that in MapReduce. Let's go back to the slide. Okay. So that what it says, bring code to data rather than data to code. It is highly scalable and it is highly available. Right? Highly scalable, we have seen, like I've given you an example that Yahoo uses a test cluster of 40,000 nodes. So imagine the scalability, right? If you think your cluster is not performing fast, add more machines. If you think your cluster is not able to store data properly, add more machines. It's so simple. Okay, and when I say it is highly available, that means if your machines are failing, data is still there. Okay, we haven't seen the case of failures if your master fails. What happens if your name node fails? What happens if your resource manager fails? There is a facility to handle these situations also. So it is highly available. Okay, we have discussed it uses commodity hardware, and we have also discussed the fault tolerance piece. That if the machines are failing, data is still available and it will still work. Okay. So this is a difference, high-level difference between your RDBMS and Hadoop. So there's a question from Bhaskar: if you want to get distinct information and the data is spanned across 3 slaves, within slave we can't reduce, right? So Bhaskar, what happens is all the outputs of all the blocks processed separately, it goes to a single machine. So, all right, it's good that I haven't erased this. So I'll just explain this. So this output, and this output, right? It would be clubbed together. Now the output, basically, the outputs will travel across the network to a single machine. Let's say that single machine can be anything. Let's say this is the node manager 2. This output will travel here. This output will travel here. This output is local here itself. Here is when you can do the distinct or the count, anything which you want, any aggregation function which you need to apply. That's what is happening in the reduce. Okay. It may be clear to some. It may be complex to some, no issues, right? There is a detailed session for MapReduce. So I have a question from Shri. How to add more systems? Does this require any changes to name node and existing data node? So Shri, the answer to this is it requires changes. It requires changes to all the machines. Okay, we have to. So there is a configuration file for installing Hadoop. So you need to edit that file in all the machines. Okay, so we have a question that can we get some practical of these explanations? Definitely, we have practical sessions which will cover all the scenarios. We will be actually doing our hands dirty in writing a MapReduce code. Okay. Right. So most of the points we have already discussed. So data types, RDBMS can only handle structured data, while Hadoop can handle multi-structured, unstructured. There's nothing called as multi-structured. That's unstructured, structured, and semi-structured. Processing, it is limited in RDBMS, limited or no data processing. In Hadoop, processing is coupled with data. Governance, it is standard and structured in RDBMS, and it is loosely structured. So these points will become clear when we will look at the further sections of Hadoop. Okay. Schema also, this point I had just called out that Hadoop is a schema, or big data is a schema on read approach. I had discussed this when we were discussing veracity. So your normal databases follow schema on write, while Hadoop follows schema on read. Okay, I'll discuss the schema thing again in the future sessions. This is just a high-level overview. Guys, just to mention the speed point here, right? This is mentioned wrong. Okay, in RDBMS, reads are fast and writes are also fast. You can just make a note of this. In RDBMS, the reads are fast and the writes are also fast. In Hadoop, reads are fast but writes are slow. Hadoop is very slow in writing. Right? This point says Hadoop is fast in writing, but no, it's wrongly mentioned. Hadoop is slow in writing. Hadoop is fast in reading. Right? Cost-wise, in RDBMS, if you're using Oracle, for example, you have to purchase a license of Oracle. That's very expensive. In Hadoop, it is free. Hadoop is free to use. If you want to have support, like if something is not working in Hadoop, you want to contact someone, you have a support team for Hadoop also. There are multiple companies which is actually giving support. There's a company called as Cloudera. So I have a question. The writes are fast in Hadoop. No, so that's mentioned wrong in the slide. Writes are slow. In RDBMS, read writes both are fast. In Hadoop, reads are fast, writes are slow. Right? We will discuss why it is slow in module 2. That's tomorrow. Okay. So yeah, so I was talking that Hadoop gives. So there are companies which are giving support for Hadoop framework. There's a company called as Cloudera. There's a company called as MapR. There is a company called as Hortonworks. So these all companies are providing support for your Hadoop technology. Resources. In RDBMS, you know how many resources you are using. In Hadoop, it grows, right? It scales. Okay. Best use case, RDBMS is used for your traditional databases, your OLTP, your structured data, transactional data, while your Hadoop is used for data discovery, unstructured data, massive storage. Right? So this is all we have been discussing since the first slide. Okay, so let's see who can answer this. I have a question already from someone. Who is the leader among 3 companies, MapR, Hortonworks, or Cloudera? I have a question from Minish. Right? So it depends on the use case, Minish, but the leader, I can safely say the leader is Cloudera. It's the most famous distribution of Hadoop. Okay. So I have the answers from others. Large data sets. That's the right answer. Yes, that's the right answer. Okay. It is also capable of processing small data sets. Right? However, the experience of the true power of Hadoop, one needs to have data in TBs. Right? It does not mean that Hadoop cannot process small data sets. It can, but the actual power of Hadoop is it's when your normal databases fail, right, for large data sets. Right? That's why Hadoop is the logo, the icon of Hadoop is an elephant. So the question: certifications doing from Cloudera or Hortonwork is good. Both are equivalent, Koratha Rao. Both are equivalent. But yeah, I mean, as per my experience, Cloudera has more. It's better for doing Cloudera. Cost-wise, also both are same. Not much difference. Cloudera is a bit expensive, right? Not much, but yeah, it's better to do Cloudera. Okay. So this is the Hadoop ecosystem. Now Hadoop. So since 2006, when Hadoop was developed, right, when Hadoop went live, since 2006 till now, in the past 11 years, Hadoop had multiple versions, right? But one version of Hadoop made the entire thing different. That's when Hadoop 2 stepped in, right? So Hadoop 1 is the old versions of Hadoop. Hadoop 2 is the latest versions of Hadoop. Okay. There's a huge difference between Hadoop 1 and Hadoop 2. Now, as I mentioned that Hadoop, it's actually a combination of two frameworks, right? Your HDFS and MapReduce. Now, what is the difference between Hadoop 1 and Hadoop 2? What has changed? Right? So the HDFS part, this has not changed. HDFS part is same for Hadoop 1 also, for Hadoop 2 also. Some minor changes, not much. For example, the properties, some property names has changed. The default values of some properties has changed. Some minor differences. Architecturally, HDFS has not changed. But in Hadoop 2, the architecture of MapReduce has totally changed. Right? In Hadoop 1, that's also called as MRV1. That's MapReduce version 1. Right? That architecture was different, and the Hadoop 2 architecture, it is also called as MR version 2, or it is also called as YARN. YARN, which is just mentioned here, this YARN. Okay, so it stands for yet another resource negotiator. We have a separate session for MapReduce, dedicated session. We'll discuss it then. Okay, so this is what your Hadoop ecosystem looks like. Okay? So at the base you have HDFS. In Hadoop 1, only MapReduce was the thing which can process your files on HDFS. Right? Then you have Hive, you have Pig, you have other frameworks. Right? All of these basically convert to MapReduce and then fetch data from HDFS. Right? So in Hadoop 1, the whole and sole thing was MapReduce. In Hadoop 2, right? So if you consider Spark, okay, Spark is not MapReduce. Spark is different than MapReduce. Spark is an in-memory kind of a processing tool. We'll discuss in Spark, but just to let you know, Spark cannot go through the MapReduce framework. If I talk about Hadoop 1, right? What happened? What changed in Hadoop 2 is now that has become YARN, and this MapReduce now it is working with YARN. So we can say MapReduce, which was the whole and sole thing in Hadoop 1, it has now become just a part, just a small part, right? The whole and sole thing mostly now is YARN. So YARN is actually a platform which can support MapReduce as one part, but it can support other tools also, like your Spark, Impala, and other tools also. Right? So this is an ecosystem. Right? This Scoop and Flume, these are basically tools used for getting data in Hadoop. Right? So I have a question: is Yarn like an operating system? No, it is not an operating system. Okay, it's a platform. It's a platform. Basically, it's a resource management platform, right? It has a control that for a particular MapReduce application or any Spark application, how much memory and how much CPU should I provide? Okay, it's a platform for your resource management. So I have a question: Flume or Scoop, is it similar to JDBC? No, it is not similar. So Flume can basically fetch streaming data to your HDFS. For example, if I have live data from Twitter, or if I have live data from Facebook, or any website which is generating logs, I want to process that data. So basically I need that data in my HDFS. For such use cases, where you want streaming data in HDFS, you use Flume. Right? What is Scoop basically? So initially, let's say, so before Hadoop, the entire data was in a traditional database. Let's say Oracle. Now, if I want to process that data using Hadoop, I have to migrate that data from Oracle to my HDFS. For doing such transformation, such transfer of data from any RDBMS to HDFS, there is a framework called as Scoop. Right? So Scoop can fetch data. Scoop uses JDBC, but it is not JDBC. I mean, internally, Scoop uses JDBC to fetch data, right? And it puts the data to your HDFS. It can work the other way around also. It can fetch data from HDFS and put it back into your database. Yeah, Flume is one directional. Okay, so Kishore is asking, is Flume looks like one directional? The answer is yes. So you're fetching streaming data and putting it to Hadoop, right? There is no use case like pulling data from Hadoop and throwing it on Facebook or throwing it on Twitter. Okay, so Flume is just one directional. Scoop, it is two directional. I will discuss later why there's a need for the bi-directional transfer. Right? So this is machine learning. Right? So machine learning is very similar to your artificial intelligence kind of system, like the things which we have discussed, right? Is your mail a spam or not? That's basically who decides it. Your Gmail or your Facebook itself or your Yahoo itself decides it, right? Now, how Yahoo knows that this mail is spam? It is basically, it has learned from the previous patterns of your mails, right? This is called as your machine is learning, right? So Hadoop has various machine learning frameworks also as a part of your ecosystem. As a part of Hadoop, the famous one is Mahout, right? It's a machine learning library which is available with Hadoop. There is one more library which comes with Spark that is called as mlib, right? mlib. Okay. So just an example of machine learning. Okay, you log into Facebook, right? You see recommendations that friends you may know. How your Facebook knows that you may know this place. Okay, so we have a question. Yeah. So what time do we end today? So guys, we are already we have reached the time. Do we mind if we continue for next around 10-15 minutes, or should we end today and continue tomorrow? What do you guys suggest? Right. So Jayesh says continue tomorrow, and remaining says okay. Kishore also tomorrow. Okay. All right. What we'll do is we'll continue tomorrow. I know there's too much. I won't bombard you with all the information in one day. Do you mind if I just finish this one slide today and stop? All right. This is the last slide for today then. Okay. Right. So it's interesting. Like if you log into LinkedIn, or if you log into Facebook, it gives you recommendations, friends you may know. Right. How does Facebook knows that these are the friends which you know? Right. It's all machine learning. It's all machine. It learns that you have a mutual friend, and it basically recommends all the friends of your mutual friends to you. Similarly, this happens in your LinkedIn also. Right? What is this? This is machine learning. Right? So for doing such kind of processing in Hadoop, right, for doing machine learning, you require data. Now, when I say Mahout can use machine learning, and the data which it uses is your HDFS data. Right? So Hadoop and MapReduce, your Mahout can bring that magic in action, and it can give you recommendations. There are multiple machine learning things. Like if you, for example, if you log into any news website, right? So it usually groups, right? It categorizes similar kind of news in a single group, correct? Like sports would be a single category, right? Your politics would be a single category. So how it knows that this news belongs to sports? That's basically machine learning. Right? All right, guys. So we will stop for today. So tomorrow we will continue the remaining slides, and then we'll go to the next module. Okay. See, I understand that. So it was the first session we have. It was all introductions were also required. I understand. We have just completed 50% of the slides. Tomorrow, I think I may take 15 minutes extra and try to cover it up. If not, we will take it in the next weekend. Right? But I'll try not to bombard you with all the information together. Right? All right, guys. So we'll stop for today. So, guys, just a request, just a reminder. So you'll be getting a survey pop-up in your session. So please fill in the surveys. Okay, give your honest feedbacks. Thank you, guys. Good night.